So,
And we're live. Welcome to the Interop. This show is all about exploring the decentralized economic networks that make up the interchain. And my hope is that my listeners will gain a better understanding of the technology of these networks, the technologies that make them possible, and the opportunities that it provides to investors and developers. I'm Sep 3.0. Today, I'm with Arjun Bhuptani, who's the project lead at Connext. Hey, Arjun.
thanks for having me, Seth. How you doing?
Good. It's great to have you on. It's great to connect again. Before we get started, though, I'd like to say, if you'd like to stay up to date and get alerted with each new live stream that we do here on the Interop, make sure to subscribe and be sure to hit the like button because that makes me happy. Also, if you'd like to support this podcast, you can stake with Interop. We're currently live on EVMOS and we're adding new validators soon, and you'll find links to that down in the show notes. With that out of the way, thanks for coming on, and I'm really excited to talk about Connext. I think when we last met, it was in Amsterdam. We were at a dinner and I was like, I want to get you on the podcast and I want to get like all the other bridges. And so far, I think we've had 3. So we're on our way to getting to, having like all the bridges on the podcast, but happy to get you on now so we can talk about Connext and how it's unique sort of in this, in this broader bridge landscape.
Absolutely.
Cool. So for listeners who are not familiar, tell us a bit about your background and like how you became to be project lead at Connext.
Yeah. Let's see. I have a background in physics. I started in crypto, specifically building on top, like infrastructure on top of Ethereum in like 2016. I was just really interested at the time in basically public infrastructure, building infrastructure like the internet that is not like owned by companies or owned by governments, but is still like globally accessible to everybody. I think Ethereum was like the first instance that I'd ever seen of like a platform that enabled that, and I thought I still think that's like an incredibly powerful primitive that will help to just like radically change the way that the types of like power structures that exist in the world today. And I ended up starting Connext because, as a result of working in the space for like a year and just mostly just it was 2016, so nobody really had anything real at the time. It was basically just like all theoretical stuff and people experimenting. It was a really, really exciting time. And as a result of that time, I kind of got a lot of conviction around Ethereum and around blockchains in general, and became convinced that like really like I needed to do something in this space. And so we started Connext with this idea of like, let's figure out how to bring this technology to 1 billion users. Very broad mission. But it's interesting because that broad mission led us to a very, very specific problem pretty much immediately, which was scalability. Because like the number one thing that we would hit whenever we talked to anybody in the space was just like, oh, it costs $40 to mint this like NFT ticket. And like, that's obviously never going to work for any user. And so Connext ended up becoming one of the first like layer 2 projects on Ethereum. We actually built the first actual layer 2 on Ethereum. It was a state channel network in partnership with SpankChain. We were one of the first like R&D teams working on scalability alongside folks like Matic, Loom at the time, which is another Plasma project, Omisego, and all of the people spun out from that and ended up starting Optimism. Like a handful of other researchers that were just around early and really curious about these problems. We've obviously come a long way since then, and we've also pivoted a little bit from scalability to Interop.
You're dropping some mad 2017 Ethereum names here, like SpankChain and all these projects that sort of have fizzled out of, I think, like the limelight of Ethereum. No, that's cool. I didn't realize that you guys have been working on this stuff so for so long, and that Connext had this history that spanned back to the last cycle. When it comes to the Ethereum space and the expansion of that ecosystem in the last couple of years, with like all these rollups and now like all these EVM chains. I was looking at the Connext Bridge website earlier and just scrolling through like the list of all these EVM chains. Can you describe what this means to you in terms of like the maturity of the ecosystem? Is it, are we going towards an ecosystem that will have tons of EVMs, or is this a trend that will eventually end up shrinking back to maybe like a few core chains? Where do you think this is heading more in the long term?
Yeah, that's a really good question. So back in 2020, we pivoted into bridging because we developed this hypothesis that there were just too many of our friends that were like research teams were building rollups like Optimism, Arbitrum, zk Sync, etc. And they were all extremely high quality teams that were backed by extremely high quality investors. And like it just, to us, it seemed like absolutely impossible that we just didn't end up with heterogeneity and fragmentation, right? And honestly, that made sense. Like it's like having everything happen on a single rollup or a single execution layer just doesn't make sense for the scalability of Ethereum, and it doesn't make sense for the scalability of blockchains in general. I think what the ecosystem has started heading towards now is this idea of like modular blockchain. So basically separating out the core pieces of like what comprises a blockchain into the individual kind of layers of value, and modularizing them and packaging them up and kind of making them interoperable and swappable with each other. So you have things like data availability layers like Celestia, Polygon Avail, etc. Settlement layers like Ethereum, and then execution layers like Optimism, Arbitrum, etc. I think right now, like, over the course of the bull market, obviously there was just like a ton of people that entered into the space. And so we saw this like rapid expansion, and it became really like, it was a very easy playbook. If you were starting a project, there was like a period of a golden window where it was a very easy playbook to just like start a chain, because Polygon had gone and like already figured out exactly the right way to do that. You could just copy paste their model. And as long as you executed well, you could scale like an ecosystem on top of your chain, and then that would accrue a lot of value to your token. And I think a lot of people realize like, okay, we can actually move to this kind of world. Now, of course, everything is down. Like usage in this entire space is shrunk. Like nobody's really using any applications anymore, and that's to be expected because it's a bear market and capital is shrunk. But like, because of that, I think we're starting to see a little bit of a consolidation. So a lot of the chains that didn't end up like kind of hitting that exit velocity have now are starting to like fizzle out, or probably will fizzle out eventually. But I don't think that idea is gone. And I think like what this market has sort of shown us is like, there is a need for moving to multiple different execution environments. Like we need that from a scalability perspective. And this is obviously a core part of the Cosmos thesis too. And then in addition to that, we also probably now need to do a better job of making sure like people sort of now need to do a better job of like understanding like which chains are actually high value, which ones are low value, which ones are going to actually have the staying power. My thesis is every single major rollup brand or chain brand is going to self-fragment into many different chains. They're all going to build their own modular layers. So like zk Sync is going to build a DA layer, Starkware is going to build a DA layer, Polygon is building a DA layer, Arbitrum and Optimism are going to do the exact same thing. And then they are all going to roll out multiple execution environments, because ultimately it's their brand that matters, right? And like the defensibility around building a single rollup is really just not very high. So yes, I think the ultimate outcome is like we'll end up in kind of a hybrid state where it's like we'll have a lot of different chains, a lot of different chain-like experiences that'll be out there, and they'll be heterogeneous. They'll be kind of cool, but the number of brands may not actually be as high as people think. Like there'll be like a set of Arbitrum chains, a set of Optimism chains, a set of zk Sync chains, etc.
Yeah, I have a similar, I guess my view like where the ecosystem is going in the next few years is a similar one, where I think that there was a proliferation, say, the last cycle was a proliferation in DeFi experimentation, mostly on Ethereum. And now what we're seeing is like a proliferation of chains with their own ecosystems. Only the core difference in how things were done previously and how things are done now is now every ecosystem will be a data availability layer, and sovereign rollups will verify the state back on that data availability layer. And that, I think that's really the play for the next cycle. And at the end of the cycle, we'll see who have become sort of the winners of that competition. And
Yeah.
obviously, like Ethereum has, and Ethereum after the merge, like has a strong chance of being one of the strong players there. We have platforms like Celestia that are also playing in this field. And then there's things that are a little bit not so clear, right? Because it's like, I mean, it's like a different paradigm, and it's difficult to see how it'll interplay with that. So things like Bitcoin, right? Like how will Bitcoin fit in this broader paradigm? Should it actually fit within the paradigm? Things like Solana, right? Yep. I think they're sort of on the periphery of like this vision, and then to some extent, the sovereign Cosmos SDK chain, right? Like any sovereign Cosmos SDK chain that operates with its own validator set, will that design, the protocol design stack and security design continue to be relevant and continue to work into the future, where they'll be competing against high data availability protocols. So it's going to be interesting to see how it plays out over the next couple of years. But one thing that is certain is that like interoperability between all of these things is going to be super, super important. And that brings us to our conversation here. One of the things I wanted to ask you is, on your website, it says that you're building the Internet of Ethereum, which I thought was interesting because, in Cosmos, we always talk about the Internet of blockchains. So what is the Internet of Ethereum, and how is it different from like the Internet of blockchains thesis as it's described in Cosmos?
It's really not. I think it's basically just it's like a mental model that we've seen like kind of resonated with a lot of people, like, building on top of interacting with Ethereum based blockchains that like makes sense. And to be honest, I really think like the Cosmos Internet of Blockchain vision is the right vision, right? I think like multiple different organizations and projects have approached it from different directions, and like we're trying to approach it from our own direction as well. Now, of course,
that sentence right there is going to make a great clip, by the way.
Yeah, I mean, I think it's when you have a bunch of different individual teams, like, and organizations and institutions, like ecosystems, finding like the same solution from different directions, that means it's the right solution, right? Like we are heading towards the global optimal, which will be something Cosmos-like, right? That like, everybody initially thought was going to be either a monolithic chain or something that was basically like a bunch of shards that were cross-linking, but really it's going to be like a bunch of modular execution layers that are going to end up interacting with each other in very similar way to like how Cosmos works. And so I think it makes sense. I think like we've specified Ethereum just because at the moment we're focused on EVM chains. That's a matter of just like pragmatism. We don't want to stretch ourselves too thin, and like we want to like try to corner a market that like really we know well and we already operate in. But I personally have like a lot of love for Cosmos. I have always thought it was a very, very amazing ecosystem, and like, my goal is to work with a Cosmos ecosystem eventually, no matter what. So I think eventually like we will have this like heterogeneous network of chains that will be its own kind of internet.
Yeah, I think we're aligned on that, and not surprisingly, what's unique about building bridges on EVM chains? I think like a lot of people that are listening to this podcast perhaps are more familiar with like the particularities of Cosmos and the way things IBC work. Yeah. And so what is particular about building on EVM chains? And, I think in that question is, what is particular about building bridges to and from version 1 Ethereum?
So I think maybe before jumping into that, let me give a little bit of just like a quick overview of the different kinds of bridges that are out there. So in that way, people get an understanding of like what options are even on the table to begin with. So like, and like what the trade-offs are of those different options, and like how they work, the way that they work, why they work the way that they work. I think the one that most people are very, very familiar with now and is still absolutely terrifying to me is multi-sig bridges. So some sort of like M of N mechanism where you have, at the worst case, it's like a single custodial actor that is relaying data across chains. And then, can kind of be like a multi-sig MPC system that is like a subset, like 5 of 7 or whatever. And then scale up to something like Axelar, which has like a permissionless Cosmos chain, and like that validator set is now like relaying data. And of course, these things have like incrementally more security, but there are still like theoretical upper limitations to like the security that you get out of that, because you're effectively trusting the security of some intermediate set of actors, and like that intermediate set of actors has not just the ability, like unlike with the blockchain where you can if you have a controlling stake, you could censor the chain, or you could fork it, but you can't actually like steal people's funds. People just fork away. With a bridge, like that bridge is effectively an oracle between two systems, right? So if you control majority stake, you can produce invalid updates, and those invalid updates can be used to steal funds. So to us, it seems like even if you can say, all right, like the economic security provided by a permissionless validator set is pretty awesome, because it works for Cosmos and like for a bunch of Cosmos chains, and it works for Ethereum and a bunch of Ethereum chains. We think that the added risk of the fact that you can actually steal funds from the system simply by being that middle actor makes those kinds of bridges more trusted, right? There's a trust assumption there. But of course, they're easier to build, way easier to deploy places, and they let you do basically whatever you want, right? You could send any kind of message through them. Now, the other ones are ones that I think people are less familiar with. So IBC is probably like extremely well known in Cosmos because it is a fantastic option and fantastic ecosystem. IBC relies on like client header verification. So what you do is you basically have two chains verify the consensus of each other. And because they're verifying the consensus of each other, you know that an update is valid because the entire validator set of this chain came to consensus that the consensus of the other chain was correct. So it's a way for chains to natively talk to each other. It's an extremely, extremely powerful tool. Of course, it's also very, very trust minimized because, in order to fool the system, you have to actually compromise an entire chain. And so like you're not adding any additional assumptions beyond the ones that you would already be making. However, the downside to something like IBC is IBC works really, really well between chains that are exactly the same and have the same consensus mechanism. IBC is balloons in complexity when you start dealing with things that have different kinds of consensus mechanisms. And in many cases, you actually can't prove consensus on chain. So like, for example, Ethereum ETH POW is extremely, you can kind of do it with zero knowledge proofs. It's still extremely expensive. It is extraordinarily expensive to try to prove Ethereum L1's consensus on chain right now. And that's because blockchains went through this really annoying phase where like they tried to be memory hard, basically have like memory hard consensus algorithms in order to have ASIC resistance. It didn't work at all. It was a terrible idea. But as a result of that, it's very, very difficult to build like clients of Ethereum right now. And so because it's difficult to build like clients of Ethereum, it's even more difficult to put those like clients on chain. And then it gets even weirder after that. So it's like, that's how you can think about something like Ethereum. But then what about rollups running on top of Ethereum? How do you build a like client to a ZK rollup that is sitting on another chain? It's a kind of an open question. How do you have like client-based communication between optimistic rollups? Well, you can't, because with an optimistic rollup, you have rollback risk. So now there is you could send a message across chains, but there is a risk that at some point within the next 7 days, that entire rollup is going to be rolled back. And then like everything that was in that message is completely wrong. So I think the kind of key issue that comes into play with like clients outside of Cosmos is that the surface area that you now have to think about, the complexity of implementation that you now have to think about is much higher. You have to go build custom implementations for every new kind of consensus algorithm. Not only is that a ton of engineering effort and research effort, but also it massively increases your likelihood of actually having a bug, right? Because you're having to write a shit ton more code and audit a shit ton more code all the time. And one bug anywhere in that system can ripple out to other chains very, very easily because of like the inherent contagion risk of bridges. No, I have I've talked a bit about like locally verified systems. That's things like atomic swaps, but I'm starting to think more and more that those don't really count as like bridges, because what they're effectively doing is like swapping assets on one chain for another, right? You're not actually having like native communication. And so if we kind of leave that to the side for now, the last type of bridge is optimistic bridges. And that's kind of what Nomad had been working on. And now I think a lot of other projects have gotten optimistic bridge pilled because we've been showing them a lot. And so they're pivoting into the optimistic model as well. And optimistic bridges are like very like similar kind of core concept. They're sort of like, you can think of like light clients as like ZK rollups and other validity proof systems. And then optimistic bridges is like optimistic rollups. Where in an optimistic bridge, it lives entirely on top of the execution layer. It's really, really easy to build. It's fairly trust minimized, very trust minimized. Gives you pretty good, very, very like good trust assumptions in practice. But the trade-off is there's latency, because you send a message across chains, and now you have a set of watchers that are like watching to see if fraud has occurred, and so every message takes 30 minutes. So the kind of takeaway here is like there is trade-offs to every approach, and the trade-offs are magnified in Ethereum because on Ethereum it's just already become this very like heterogeneous, muddled ecosystem where there's a lot of different kinds of chains and different kinds of execution environments.
Yeah, no, I think that about sums it up. And I wanted to come back to the different types of bridges, and you guys have a great post on your blog where you walk through like this natively verified, which you described earlier, and is what IBC does, where you have like one chain verifying another chain. Externally verified, where you have essentially a group of actors that is through a multi-sig or through some sort of like orchestration mechanism verifying each chain and then passing messages. So like a simple example of this would be a multi-sig. A more complex example would be a set of validators, something like Axelar. And then we have locally verified, and the Connext falls into this category. But I guess when I was reading the post, like it wasn't obvious to me how natively verified and locally verified actually are different at a practical level. So like what on chain, what is actually happening and what is performing the verification?
Yeah. So this is one of the reasons why I was kind of saying I sort of moving away from the model where I consider locally verified systems bridges rather than just like liquidity networks and like mechanisms to get tokens across chains. And the reason is that so what's happening in a locally verified system? So examples of this are like atomic swaps or things like HOP, right? Where what you have is you have an actor that has liquidity on one chain and liquidity on another chain. And like you send liquidity over here and then they send liquidity over here. And that can happen through whatever mechanism, but you can actually keep that fairly trust minimized. But what you're doing as a user is you have a one-to-one relationship with this actor. And because you have a one-to-one relationship, you can swap assets with them without ever interacting with the rest of the chain. So the rest of the chain doesn't even really need to care that this happened. They're just like, oh, this person just sent a transaction. From the perspective of the chain, it's just like a normal transfer, right? This is, of course, different than a like client-based system, because in a like client-based system, you actually have like fully expressive communication. You're not just like, it's not just like, oh, I'm interacting with a counterparty to do like something where the counterparty and I can just like negotiate some agreement to do something. There's an entirely different set of use cases which are generalized, and I can get into those in a second, but an entirely different set of use cases which are generalized that can only be done if like one chain is actually able to prove messages to another chain. And that's kind of outside of the scope of locally verified systems, because you're sort of saying, we don't need to prove anything if like you and I can just negotiate something between the two of us. Now, where does that difference lie? That's actually really, really interesting thing that like I think we have explored quite a bit, because we really wanted to like push the limits of locally verified systems as much as we could. And I don't think a lot of people have as good of an intuition about. And what we found is like, if you take like a range of use cases, right? So for example, let's say you are, this is an Ethereum based example, but I guess it can work on Osmosis too. So say you want to like swap on Osmosis, but you are a user on another chain. That can happen using a locally verified system. And the reason that can happen is because, what I can do with you, Seb, is I can, you want to swap USDC to Osmo. I can basically just pay you. I can put up some funds and say, here is $100 worth of USDC. If you go swap $97 worth of USDC into Osmo and send the Osmo to me. And that 100 USDC is locked in escrow until you actually send that transaction to me. And what I've basically done is I've done cross-chain communication, right? Like I have off-chain interacted with you, negotiated this agreement. You have done this transaction on my behalf and paid me. The reason that works is because the swap function on Osmosis is unpermissioned. It's basically an unauthenticated function. Anybody can call that. Anybody can do a swap. And so it's totally okay for some service provider to do it on your behalf. And you can encode on chain that they do this in a way that's like where you can enforce that they will actually pay out the funds to you. However, let's take a slightly different use case. Say Osmosis needs to go through a governance upgrade. And And so now this is a function, this is something that is happening as part of Osmosis' system that only governance can actually enact. It can only be enacted through a certain set of permissioned actors. And now imagine, I mean, I guess this isn't exactly, this is kind of where the analogy breaks down and works a lot better with Uniswap. But say, for example, like this permission function is actually being enacted by a group of actors that are on a different chain. So like some group of 5 multisig owners are the ones that are making this update on Osmosis. And they need to send a cross-chain message from whatever chain they're on to Osmosis to upgrade the system. How does the Osmosis chain know that the message came from those 5 actors? Because this is an authenticated call, they need to prove that it came from those 5 actors. And the only way to do that is to actually prove that that was included in the other chain. There's no possible way for those 5 actors to pay a service provider to do it on their behalf. Because if they paid a service provider to do it on their behalf, that service provider could just do an upgrade whenever they wanted. And there's also no way for the 5 actors to, I mean, maybe they could have like a ring signature or something like that, collectively like sign a threshold signature, but it's a little bit of like a custom use case. So imagine if you scaled this up to like a governance system of tens of thousands of participants. Obviously at that point, there's no way for them to come up with any kind of cryptographic proof that would actually prove across chains that this was supposed to happen. So that's actually where all of this stuff hinges on. Like the core thing that any bridge is trying to do is to figure out a way to have one chain prove to another chain that something happened, and that's it.
Easy, right?
Very difficult to do in practice, but
yeah. We can just hire some guy to do it.
Yeah. If chains could sign messages themselves, this would not be a problem. Like if we had the cryptography, if we could just invent the cryptography to do this, bridging would just disappear overnight.
Yeah. What makes I guess for like I feel like there's a little bit of bridges are getting a bad rap, and
we're in the trough of disillusionment for bridges right now, for sure.
There's so anything that, well, I think there's a few things. One is what a bridge is, I think gets just put under one umbrella, right? So all these different technologies sort of get put under the same, like this is a bridge, right? Without differentiating what is natively verified, externally verified, what's a multi-sig, what's just some guidance basement, and like what's locally verified, etc., optimistic, etc. Then what happens is bridges get hacked, as has been the case, and most recently, and we'll talk about it, like Nomad was hacked. And people lost funds. I lost funds. And so, and then there's like this mistrust of anything that gets labeled a bridge. So how can people make better decisions about what technologies to use? And I guess, one big question that, and I'm sure you guys have thought about this, is how do you instill trust in people to use your tech when no one, most people that use it, I guess, maybe don't know how it works, or, I think like most people using Axel are like probably have no idea how it actually works, right?
Yeah, I mean, to be fair, I think most people using the internet don't know how it works.
Yeah, exactly.
I mean, I think it's difficult. So I think you're totally right. We're like in a period right now where we're getting close to hitting like bottom sentiment for bridges. And I think it's been like a series of ever increasing amounts hacks, right? Like, like when the $300 million wormhole hack happened, I was like, all right, fuck, this is it. Like, this is basically like, people are just going to hate bridges now. And then we topped that with the like $650 million Ronin hack. And like the funds weren't even returned from that. So it was just like, like, that was already just such a bad thing. And I think the one thing that was kind of like helping the bridge narrative along was this idea that like, okay, well, we can have safe bridges. Like here is Nomad as an example of a really, really safe bridge. And then Nomad got hacked too. And like, I think it just goes to show that like, this stuff is really fucking hard. It is. Like blockchains themselves are really, really difficult to build. But if you think about it, every single blockchain, like basically every single blockchain that has been built has effectively at some point, like at least like intellectually been a fork of Bitcoin. right? So we've had like Bitcoin like created a blueprint, and then people just forked the shit out of it, and then it's like evolved over time, and like every change has been like incremental on top of something that already existed. Whereas with bridges, it's not like that at all. It's like fully from scratch. We are trying to figure out how to think about these problems from the get-go without any sort of context on like the right way to do them, and build them, right? So the scope of risk is higher. In addition to that, I think like there's also like a big difference. Like, of course, there's like the economic security of bridges. So you have, you know, the economic security out of a 5 out of 7 multi-sig is obviously really fucking terrible, right? The economic security of, you know, Layer Zero's relay Oracle system is really, really, really not great. But at the same time, you also have implementation security, and that's the other piece that I think is like really, really underestimated and appreciated, which is like the vast majority of bridge hacks are not happening. I mean, they will eventually happen because of like economic attacks and stuff like that, but right now they're happening because of like bugs in the code. And unlike with, you know, a chain, in a chain, like you'll have like a consensus failure, but you can restart the chain. You can roll back and restart the chain. You can't do that with a bridge. Like once a bridge gets hacked, it's hacked. There's nothing you could really do about it. Yeah. So I think the stakes are just far, far higher.
Yeah.
Now, how do we actually get to the point where people trust this stuff? I think in general, there needs to be a much, much larger conversation about security for bridges. We are now trying to, we've done a bunch of analysis on this, and we're like trying to publish a lot of this work that we've been doing. Lane, one of my co-founders, gave a talk at Stanford last week about bridge security, which just like breaks down the different kinds of like, basically like the security surface area of cross-chain communication in general. And then also talks about like, well, why do we even need this in the first place, right? Like, do we actually need this stuff? And the reality is we do. Like, there's no way for us to, if we want this ecosystem to succeed, we have to figure this problem out. We have to. Like, there's like single blockchains just don't scale. They just don't. And there's no point in having a bunch of single blockchains that don't talk to each other. So like I think the answer is going to come down to a bunch of different things. There's going to be the economic security pieces, which we've been harping on a lot. I think in general, bridges are going to have to start holding themselves to a much higher standard in terms of economic security. Like no more like 5 out of 7 multi-sigs, no more situations where like you are storing a bunch of keys on a server somewhere that can get hacked. That's fucking terrible. Like that just cannot happen. Like if you're like an early stage bridge, like it might make sense. But if you have hundreds of millions of dollars, that is like, you wouldn't put hundreds of millions of dollars into like a 5 out of 7 multi-sig that like you're putting like on your own computer. That doesn't make any sense either. Like where the keys are just like stored on your computer. That's terrifying. And so it doesn't make sense to have that be like the MO for bridges. And I think like optimistic bridges are still like the right way to move forward there, because you can turn any multi-sig bridge into an optimistic bridge very, very easily. And like, it's like, like obviously that provides competition for us when you do that, but I'm advocating for it because it's just better for the industry. And then beyond that, there's like the implementation risk. And I think like implementation wise, every single bridge now needs to move towards a pattern where they just implement like a set of standards that we're actually we're like thinking about doing this. We've talked to a few people about it. Polygon has also expressed interest in doing this, but basically building like a bridge security framework that is just a set of libraries on Ethereum that every single bridge can inherit, and then maybe porting that over to other ecosystems too. And those libraries are like heavily audited, very standardized, and they just provide some core functionality that every single bridge needs for security. And that will be things like rate limits, right? It should not be possible to exit more than like, let's say 10% of the funds on a bridge of sufficient size within a certain number of blocks. That just doesn't make sense, right? Like if that's happening, it's probably a hack and you should just halt immediately. So any situation where that happens, the bridge should just halt. Having watchers, even if you're not an optimistic bridge, just having a system where like you can have a decentralized set of actors just stop the system because they saw something go wrong. Having like even just basic like disconnections, like being able to like limit contagion risk by basically saying like, okay, this chain has gotten hacked. You know, a chain got 51% attacked. Let's cordon off that chain by disconnecting all of the bridges that interact with it. So now at least there's like no outflow of funds from there. And having that be built into every bridge system, because a lot of systems don't even have that right now. They don't have the granular control to say, okay, this system is just going to get shut off, or this chain support is just going to get shut off.
Yeah.
I think those kinds of steps are what's needed at this point. Like we need those like circuit breakers, basically.
Yeah, and I think like practically that makes sense. I think if I'm playing devil's advocate here, there's definitely a case to be made for well, there's definitely a fear that circuit breakers could be used to censor if not sufficiently decentralized, or where
Yeah.
You know, having a multi-sig that implements a circuit breaker, you know, like is not, yeah, I think for a lot of people, that doesn't pass the bar of like
Yeah.
a system being fully decentralized. So yeah, I agree that this is not easy, because like once you start getting into sufficient scale, if there's a hack going on, you're not going to wait 5 days for a governance proposal to go through to turn
Yeah, it
off
doesn't make sense. Yeah.
to turn off a chain, or turn off a bridge, or like cordon off like a blockchain, or like you said.
Yeah.
I'd like to talk about
I
the
think
different.
I think the
Sorry, go ahead.
automated rate limits is really the big one. Like I think I'm like the more I think about it, the more I think having just like automated rate limits on bridges is just makes sense, right? Like it just doesn't make sense for if like any bridge that has a bunch of liquidity in it, like Nomad, for instance, right? It doesn't make sense, realistically speaking. Like, you know, maybe 10% isn't enough. Like, you know, as if you're like a relatively smaller bridge or something like that. But you could just scale that with time, and set like caps and basically continue to increase the caps over time as like you get better and better security. That's actually what we're doing now. We have our new security model. We're going to be like publishing a blog post on our security framework, but it's just, we were just like, after everything happened, we were like, wow, yeah, we just need to like really go be astoundingly pedantic. And so we're just like setting caps, and like where you'll only be able to put a certain amount of liquidity into the bridge, and then we'll keep increasing the caps as we do like formal verification and basically have rate limits. And then as the rate limit size goes down, the cap limits will increase. So and vice versa. So like, you know, you have $1 billion bridge, 5%, you know, or something like that. You say 5% of the liquidity should not just disappear overnight. That's obviously a really, really big concern.
Yeah. Yeah, I think this makes sense. Like if you can have these rate limits and then they get reevaluated over time, like through governance proposals and things like that, then probably a good solution, at least in the interim. Yeah, well, I'd like to talk about the stack a little bit, because I've used Connext to move funds across EVM chains. I was looking at some of the documentation and stuff, and I noticed you were talking about IBC and XCMP, which are these, trust minimized, natively verified protocols. And I see that in your stack, and I'm like, how does that fit in there? So, what's like the future state of Connext, and how does how do things like IBC fit into the more long-term Connext vision?
Yeah. So I mean, I don't think IBC is going anywhere. I think IBC is an incredibly powerful system and protocol. I mean, it's a framework, right? It's a framework for doing cross-chain communication with like pluggable proving systems, and the main proving system is light clients. I think in some cases IBC and light client-based IBC is just too heavyweight for certain types of systems, but that doesn't mean that it's like a bad system. It just means it's not like a one size fits all solution. And realistically, there just isn't going to be a one size fits all solution. That actually, I think, is my biggest takeaway from a lot of this, is like in the long run, it's probably going to be the case that like just like the internet itself, there will be like a bunch of heterogeneous different networks, and like we'll have ways for those networks to like communicate with each other. You'll have basically like the blockchain/bridge version of BGP, which is the Border Gateway Protocol, which like lets you communicate between networks that are speaking different languages. And I think that makes a lot of sense, because like in trying to scale a bridge protocol to do everything, it becomes bad at anything. So my kind of thesis is like, bridges are going to go in the same direction that blockchains are. They're going to become really modular. We are already kind of doing this. We have kind of started repositioning ourselves as like a liquidity layer. And then we especially like when we were working with Nomad, like we were positioning ourselves as like the liquidity layer, and then Nomad was the messaging layer. And so like when you any interaction that like anytime developers did an integration that was into Connext, and like Connext would like kick off transactions, and then we would pass messages down to Nomad, and then all of that would kind of go across chains together. And so it gives you like this full stack experience, and it makes sense to do that because there is going to be instances where you'll need to like swap these things out, I think, realistically in the long term. So the reason that things like IBC and XCMP have been in our docs for a while is because like a part of our thesis has been that like, IBC will provide incredibly good communication amongst Cosmos chains. So instead of trying to like beat IBC at its own game, it makes sense to have just a consistent interface. And I think like Composable, a couple of other projects are thinking about things in the same way. Basically have a consistent interface across all chains and like have like underlying routing to get to the right kind of bridge network. So like the messaging layer can kind of
falls
be
in this category where like of having like a consistent interface that, and then I guess to talk to all the different protocols. Yeah,
I mean, I think it makes sense. Now on our end, I think like the liquidity layer piece is another piece like that, where it's like, you know, it may make like the network effects of liquidity layers may make it more of a like less sort of like fragmented. It may actually end up begetting a more kind of long tail distribution rather than a fragmented one. But I'm absolutely certain that there's no way, like, you know, a lot of our competitors are just they're not gonna like die. Like, you know, we'll compete with them even if we win more market share, even if they win more market share. Like, we're all going to continue existing because this market is growing so much. So like by the time it becomes competitive enough that you know, we're now like competing to take each other's market share and like competing to take each other's users rather than just like growing along with the market. It's going to be far down the line, and I'm sure both like all of the core teams will by that point have just like exited the community anyway. So I think like for now, it's going to be a heterogeneous ecosystem for sure.
Yeah. So is this the in your stack, like you have this NXTP, which is like the next protocol, is that right?
Yeah, that's basically that's like the liquidity layer that we have. Okay. And that's the kind of like locally verified system that allows you to send basically swap tokens and do some type of like limited types of calls across chains. Now the idea was like to layer that on top of a messaging layer like Nomad, because then we don't need to. So this is one of the kind of like downsides of what exists currently, is like we use signatures as a mechanism to verify like two parties interacting across chains, right? Needing to go and actually sign additional transactions and stuff is just a giant pain for users. So like abstracting that away involves sending those messages through the chain itself, through some other bridging mechanism or through some messaging layer. And Nomad was playing that role. Like we would basically like fast execute transactions on top of Nomad. They would happen immediately instead of in 30 minutes. And then afterwards, there would be like a reconciliation that happens once the message goes over the Nomad bridge. And that model works across the ecosystem. Like it works with rollups, it works with, you know, like the Polygon POS bridge, it will work with IBC as well.
Okay, so the idea is to like leverage this liquidity layer and to then work with like rollups, protocols like IBC, other bridge protocols that might exist, you know, in ecosystems like XC, MP, and so on. And yeah, I guess to come back to this idea of, you know, trust. You know, when it comes down to it, though, like Connext being a liquidity protocol, there's always a risk that those contracts can get hacked. Like that is a non-zero risk. You know, are these rate limits and these sorts of mechanisms to help prevent, you know, massive liquidity being exited from the system? You know, are these the things that you would be a proponent of implementing here at this level, or are there like other things that we can do here?
Yeah, I mean, we are implementing these things right away, right? Like we have caps and stuff that will be going live with our system very, very soon. We have we think that everybody should be doing it immediately, because it's just like it's like this whole space can't move forward until bridges stop getting hacked. It's just, you know, it's like, and this happens, and it happened, for instance, with DeFi. There was a period in DeFi where like there were just a ton of hacks, and it was just because like, you know, people hadn't figured out what to do yet. Like we didn't have great practices in place, and like there were a lot of scams. There was a lot of like random shit being built that just had no right to be built, and it was being shipped off to mainnet without an audit, and like people were aping tens of millions or hundreds of millions of dollars of liquidity into it, and then it was getting hacked. The difference is that the scale of those hacks is a lot smaller, right? Like with bridges, you know, it's you're not just talking about like, oh, this is a single application that had like, you know, $10 million in it or $50 million in it, whatever. It's like this bridge is now the gateway to an entire blockchain, or sometimes several entire blockchains, right? And like if that bridge disappears, that entire chain's ecosystem is fucked. Like, every single person on that chain is now holding unbacked assets. It's a nightmare scenario, right? Like the stakes are just so much higher. And so I think like as a result, the security practices need to be so much higher, right? We as a collective need to do a much better job of like being careful and focusing on doing it the right way rather than, I mean, it's so hard because everybody wants to scale. But we need to focus. I think like I think we need to really consider like, okay, if there is $100 million in this bridge, like that needs to be an extraordinarily robust system.
Yeah. I mean, I think coming to consensus around good security practices is certainly something that the industry needs to do. I think there's also a higher level amount of consensus that needs to happen around what are the technologies that are best suited for usability, security, and compatibility across the board. And I think IBC has a lot going for it in terms of being able to aggregate a lot of use across ecosystems, so like beyond just like the standard Cosmos SDK chain. But it feels like the crypto industry is. I mean, look, other industries have been through this before. Like we have standards that exist in all sorts of domains. So from things like video encryption and compression standards to like MPEG and things like that, or fucking plugs, man, like wall outlets, right? Like, I mean, these standards have been around for a really long time. But standards exist and like in computer science and like whether it's hardware or software, there's like tons of standards that exist that have been adopted and that are like where there's some dominant standards. And the way that industries have done that is like consortiums, organizations like the W3C, right? Have working groups, and they work for years to come to standards on things like HTML and CSS and like all these web technologies that we use. And then you have like IEEE, and they work on other types of standards. And I'd love to see these sorts of governance bodies gain traction in crypto. And one of the things that like seems obvious is like a starting problem is bridging and interoperability. But I think the trade-off there is that then you just have capture by massive companies. So who sits at the W3C? Well, Google, Apple, Firefox, like Mozilla, and some universities, of course, but like not the individual developer or the individual web user, or at least not to my knowledge. And so there's definitely a trade-off to growing as an industry and moving down this route. Is that the millions of people who use crypto and who think they have sort of like a stake in the way these technologies get developed suddenly have less, or at least less apparent say in how like these things end up being implemented.
I mean, it's definitely a huge challenge because it's like with situations like the W3C, like, you have these very, very large organizations that are like sort of competing with each other, but they're also large enough that they're in a position where like they're frenemies, right? Like they work together and simultaneously work together and compete with each other. I mean, like Google is larger than nation states. Like it's just ridiculous. And I think like the other difference here is like you have a bunch of startups, right? Like small to mid-sized organizations that are just like trying to find product market fit and trying to make sure that they like survive. And so the incentives are also kind of difficult. I mean, I've been in this situation before, like when I was working on, like Connext was working on state channels for a while, and there was a huge like push to try to do a lot of standardization around state channels. And there was always this like big question of like, okay, well, Bitcoin has done it, right? Like everyone in Bitcoin is just like following the same interface around Lightning. Like, why can't we do the same thing with state channels? Why are there so many different organizations with like completely different implementations? And I think the answer to that is because like Lightning is kind of a monopoly, right? Like it was basically one monopolized sort of like mental model that hasn't really like changed at all. And I mean, it's still kind of being. I mean, obviously there's like multiple different organizations and different people like contributing to it, but it's not a bunch of different ideas around doing scalable payments on Bitcoin. It's like one single idea. People are
the feature set on Bitcoin sort of makes it difficult, I think, to come to other solutions on how to do this, right? You're already like in a very restrained environment, and so like one good solution is probably the only solution.
The solution,
yeah, the solution, yeah.
I mean, I think like the other piece of this is, of course, like, for better or for worse, I think a big part of the way that standards have been set in the space is basically just like projects winning dominant market share and then just setting something, and then it ends up being something that everybody adopts, right? Like it just sort of becomes a colloquial thing.
Yeah.
And I mean, it doesn't not work. It has led us to a bunch of shitty standards, but it doesn't not work.
Yeah.
Or it's arbitrary, right? Like 18 decimal points in Ethereum ERC20 tokens. Kind of ridiculous decision. Doesn't really make any sense. 18 decimal points. It's a lot of decimal points. It's a lot of precision for. Why does it make sense?
Yeah, and I think EVMOS maybe has a different standard there. I think they don't have 18 decimal points or something. For some reason, I don't know. I have to ask Fede. Yeah.
And I think the other piece of this is also going to be that like the challenges that each ecosystem has around things like bridging are also going to be slightly different, right? So like, for example, like a lot of the big challenges around like bridging in the Ethereum ecosystem is going to be around like the security of the bridge. Whereas in Cosmos, it's kind of a solved problem. It's pretty awesome. However, Cosmos has another problem, and IBC has this problem, which is like IBC lets you do like point-to-point communication between all of these different chains, but it doesn't necessarily like discriminate between the security models of the chains themselves. So like if you can have a extremely secure chain connected via IBC to a chain that only has like a handful of validators, and people go and 51% attack this chain, and then they can use that and IBC to then go attack this chain. That is also itself a problem.
It is a problem, but I see it as less of a problem. And like the analogy that I have here is, you can be in a city and use a bridge to go to the bad side of town. You do that of your own volition, and knowing that you're going to a part of town that's like maybe not the best part of town, but at least you're not gonna, like, the bridge is not gonna fall under your feet.
Right. But I think in this case, the difference is like the bad part of town there's no sort of like mechanism on the bridge to start. I mean, this is a bad analogy. But I think the issue is basically
if you go to the bad side of town, you can get beaten up, or like you can get mugged. Right?
No. But also everybody from that side can come to the good side of town and do whatever the hell they want. There's nothing stopping them. That's the issue. And the problem is like in this.
In the real world,
the problem is basically like you have this like, for example, like the big sort of thing that everybody pushed back on with like the Ronin bridge and everybody was really upset about was like it's a 5 out of 7 multisig, right? Now imagine if and like that was the issue. Now what was happening with Ronin was like it was not only the fact that the bridge was a 5 out of 7 multisig. It wasn't. It was basically like the entire chain was reading the state of Ethereum, right? It was actually like a trustless bridge going the direction of Ronin. The problem was the Ronin. There was only 7 Ronin validators to begin with. Like the 5 out of 7 was 5 out of the 7 Ronin validators. The same exact problem exists in IBC and Cosmos, right? You could have like the Cosmos hub chain connected to another Cosmos chain with 7 validators that has a 5 out of 7 threshold for making updates. That will have, and you're communicating using IBC. When you do that, the fact that you're using IBC will make 0 difference. That will have the exact same security as the Ronin 5 out of 7 multisig. And that's a problem, right? Like that's an intrinsic issue that I think a lot of people don't realize. And it exists, I mean, it exists everywhere, but it ends up being more of a concern on something like in the Cosmos ecosystem and for Cosmos related bridging than for like Ethereum related bridging, which has happening on rollups, and you don't have this problem at all.
Yeah. I see what you mean, but I still feel like, I mean, I feel like as long here, like when you move tokens over IBC, if you're moving your tokens over to somewhere that has good security, your tokens are not getting lost in that transfer transaction. If you're moving your tokens to somewhere that has bad security, then that's a risk that you're taking. And now, do we need to have secure chains and maybe like some some sort of community vetting around which IBC channels sort of get pushed to the top, or which IBC channels are sort of notified as, okay, like this chain is not passing a certain security threshold. Like that's more of a social problem than a technology problem. And like we've solved that in some sense with like web technologies. Right now I'm like looking at a website that's got a little lock on it. I know it's a secure connection because that's like a user experience thing that we've developed, and we've come to consensus around how to do that. I think we'll probably end up with the same thing with blockchains, where you'll have chains that pass some sort of security or like trust threshold, and those can be sort of like labeled or somehow like indicated in user interfaces to users.
Well, not just user interfaces, also on-chain integrations. Like, for example, as an application or a chain that is connected via IBC to other chains, you will not be able to accept connections from chains with below a certain level of security. Because if you do, like, for example, say you have a Cosmos chain that has like the bank module installed, right? And like that bank module is connected to like 3 other chains connected via IBC. So like say you're Osmosis, right? You're connected via 3 other chains. And 2 of those chains are totally fine, right? They have a high amount of security. One of them doesn't. The problem is that one chain with a low security can not only attack Osmosis, it can also through Osmosis attack every single other chain. And they could do that basically. And it could even, unless you had a check to stop this, that chain that like the Osmosis bank module is connected to can basically go and mint an arbitrary number of tokens on Osmosis. It can do this because it can come to consensus independently that, oh, there are a bunch of funds going through the system, even though there aren't. That can be used to mint funds on Osmosis. And then those funds can then be effectively like laundered out to every other chain. And it spreads, right? That's the contagion.
They could mint funds. They could mint funds of their own chain. Like they could mint their own token, but not.
They could basically just pretend as though funds were sent over the bridge, even though they weren't.
Oh, okay. And so therefore you have a problem like with fungibility,
So from the perspective of the Osmosis bank module, Osmosis is believing messages that come over IBC because it thinks whatever's coming over this is corresponding to something that happened on the other chain. And what this message is telling me that there were, $100 million of tokens were burned on that chain. $100 million of USDC was burned on that chain. And so I get to mint $100 million of USDC here. But and this can happen without compromising IBC whatsoever. That chain could just be 51% attacked to pretend to mint those tokens and not actually mint them to begin with.
I think this sounds really similar to the issue that EVMOS had with there was a bug in EVMOS early on where they had to this was sort of like the bug that halted EVMOS to begin with, right? Is like that there was a way to create arbitrary chains and then send IBC transactions pretending that
to EVMOS.
To EVMOS. Yeah, I mean, I have to go back and look at it. It sounds like a similar sort of attack.
There was a post that was written by Vitalik on this exact attack called multi-chain, not cross-chain. I mean, I think the conclusion of the post is that bridging is terrible, but I don't agree with that conclusion. I think there are ways to curtail the risk of this, but it is something to be concerned about for sure. Yeah.
So we sort of talked about this throughout the conversation, but sort of like peppered through, and I can see here in the chat that a lot of people are asking about the Nomad hack. So how did the Nomad hack affect Connext and Connext users? And I should probably get their team to come back on the podcast. But can you talk to us what the status is there about how they're progressing to either like get the funds back or more importantly survive long term as a team as a project?
So I think I think the first thing to say here is so we're super close to the Nomad team. We were obviously extremely closely partnered with them on a technical basis, but even more generally, James was one of the first people I knew in the space, and I had basically knew him because I randomly emailed him to ask him for advice when he was working at Storage back in 2016 or 2017. And he was one of the few people that I had emailed out of 50, 60 people who was nice enough to reply and actually have a conversation with me. And I think in general, the team is just a bunch of people who really, really, really actually give a shit about this space and really want to push bridging forward. They wanted to like build something that mattered and actually helps the ecosystem. And they, I think like, you know, we're doing a lot of this for the right reasons, right? They wanted to like make bridges more secure using optimistic systems. So what happened was not only, I mean, unlucky because I guess it's just like this is something that should have been caught, but it just wasn't. Not only were they like unlucky, but this is also just like extremely devastating, extremely unfortunate that it happened to a team that really like has been trying to do the right thing for so long. I think one of the things that was unique about this attack compared to any other hack that's happened in the space is like it was less of a hack and more of like a decentralized looting. Like you know, we when it was happening, we spent time like trying to figure out, like in the early days, trying to figure out like what actually happened and things like that. And it seems like a lot of the transactions that were made basically by mistake, right? It was basically like the initial set of transactions that was made by people who sort of just happened to discover that this was a vulnerability, but they clearly, whoever started it didn't even realize that it was a vulnerability because they didn't take all of the funds. They just submitted a transaction, and then what ended up happening was that from the perspective of like mempools on Ethereum and like bots in those mempools, this was a front runnable transaction. This was a profitable transaction that they could MEV snipe. So they were just like generalized front running bots that were just like, oh, this is cool. I'm seeing this as a profitable transaction. I'm just gonna copy paste the transaction with a lot more gas, and I'm just gonna keep like, and they all started doing that, and so the entire mempool filled up. And that's actually how it was discovered. And once it was discovered, it was posted on Twitter, and then it went viral. And it's interesting because the funds from the Nomad hack ended up at like 300 different addresses, not just a handful of like, not just like, oh, this was a hacking group. It was like, yeah, so many people ended up with funds. A lot of the people didn't even know.
ENS names.
Watermelon, watermelon.eth.
Yeah, these guys.
The goat. But yeah, there was a lot of like, I think it's just like fascinating what happened, and obviously horrifying from the perspective of Nomad, because this was like a hack that happened over an extended period of time, and watching the kind of numbers go down and trying to rescue what you could is obviously such a difficult task. I think like because the funds are spread out over so many different addresses, the complexity of dealing with this hack is just so much higher than anything else that's happened, right? Normally what happens when a hack occurs is like, you know, like teams will work to figure out exactly what happened right away, and then like the first thing that they will do is like submit, you know, just like submit like an on-chain transaction with a message to the hacker saying like, okay, great, well done. Like, can you please give us the money back? You can keep like 10 to 20%, whatever. And because that happens quickly, and because that is, in most cases, it is like extremely difficult to launder very, very sizable amounts of money, most hackers will actually just take that deal. And so teams will get back the funds immediately. In Nomad's case, it's not exactly possible to do that. I mean, they offered a bounty and things like that, but like there's just so many people involved in this that like figuring out where all of these funds went is just a much, much bigger challenge. And the other piece of this is like
paid back, like
I think it's about 20%, or maybe it's more now. Actually, I haven't checked recently. It's somewhere between 20 and 30. But yeah, I think like the other thing that made this more complex is that because this wasn't actually like an explicit hack, it was more just like a thing that happened accidentally. A lot of the addresses are doxed, like a lot, like the majority of them are doxed. And so I think like Nomad has had to take a very sort of pedantic and pragmatic approach to work with like chain analysis and work with authorities to figure out like, okay, like how can we track down these addresses, link them to exchange accounts. Now, once that process gets started, it just becomes complex, right? Like you're not dealing with a bunch of people in crypto who like move at the speed of light. You're dealing with like organizations that are used to operating on like year-long time scales, right? Like I'm not saying that that's actually the time scale that where everything is going to transpire, but like the rate of change is much, much slower. I think you know, I think like the Nomad team is still working day and night to try to figure this out. They're still like in contact with authorities. They're still trying to target you know, specific accounts and get in touch with them directly to see if they can offer bounties and negotiate deals to get funds back. And they're also working on plans for not only like restarting the bridge, so like to be able to allow people to exit funds, but also to like find potentially other creative mechanisms to like reimburse users. And I think they feel extremely, extremely strongly that this is like a big thing that they need to make sure is like right for people. And I have a lot of faith in that, because like they are fundamentally very good people. It's just like, it's hard to balance the needs of everybody, especially when everyone is like yelling at you in public all the time. And when you also have to kind of like interact with like institutional actors like investors and chains and authorities and chain analysis and things like that, and balance their needs as well. Are they going to recover? I don't know. I'm still in extremely close contact with Pranay. I have a lot of faith in the team. I think they are top notch. I think that they're going to do the right thing no matter what. And I think that they are going to try their best to recover. I just think it's going to take time. That's the big thing, is like, I think in general, I think nobody can really expect a lot of material change on this, probably for the next like 3 to 6 months. It's just going to take a lot of time before they get back to it.
Yeah, I think that I would multiply that timeline by 2 at least. It just feels. Yeah. I think the biggest challenge that they're going to have is a challenge, and getting people's trust back, and having people trust the Nomad brand and the team behind it. And for rational folks who know them and know the sort of behind the scenes of how they're implementing things to prevent this from happening. Yeah, sure. Those folks might want to use that again. But for the average person, I think it's going to be difficult to get that trust back.
Yeah, it is. Yeah. And that's one of the big challenges now. It's like, it's really unfortunate. I mean, it's one of the huge challenges, right? It's like Nomad isn't like an organization like, like Wormhole, for instance, like this risk existed with Wormhole when the Wormhole hack happened, right? Whereas you could have just been like an entire depegging of like most of the Solana ecosystem. That would have been incredibly horrifying for Solana. Yeah. And Jump immediately backstopped it because they realized what happened. And like that happened for Wormhole because, Wormhole is owned by Jump, and like they have a huge incentive. They have such huge bags and everything else in that ecosystem that like not doing that would have meant like torching a bunch of their own capital. And so it was just like a good cost benefit analysis. That doesn't necessarily exist with Nomad, because it's not like the same. They're not like 100% owned by a large scale market maker, which is, it's a good thing, right? Like that's a big part of what made Nomad fantastic, was like they were a very like pragmatic team that was very independent, trying to like actually become a public good. So yeah, it's difficult, and I think like we'll sort of have to see how things progress. On our end with Connext, we still love the Nomad team. We're still trying to support them however we can. We understand that right now, like I think one of the best ways to support them is just to give them space and like let them have the time to figure this out. And so we've kind of shifted we actually came up with an alternative mechanism for like messaging as like a temporary solution that lets us still go live with like about 1 month delay to our timeline. So that'll roughly be like at the start of October. And we basically get to have exactly the same functionality we did before, but we're using existing bridges as transport. So things like rollup bridges, Polygon POS, et cetera. So you're not taking on any additional trust assumptions beyond the underlying chains themselves. And it has like some trade-offs. There'll be like some fixed gas cost overhead that the team, we will subsidize. There will be some like added latency for the slow path of transfers, but it's a good interim solution. And then in 6 months, we're going to see what happens. Like if Nomad's able to recover, where the market is, and try to figure it out from there.
Okay. Yeah. Well, I wish you guys all the best with that, and certainly wish them the best as well, and hopefully they recover from this. Otherwise, market will decide if that's a public good that they want to keep supporting, and if there's a void there, I'm sure someone else will fill it. Yeah. So before we wrap up here, when next token? Yeah.
Yeah. So for those of you that know, we had announced the next token a while back.
In Amsterdam,
In Amsterdam, yeah, it was extremely unfortunately timed because it was like immediately prior to everything. Like it was like a little bit before everything crashing. We were actually very, very close to launching the token when everything crashed. And we just decided to we like made the decision of like, okay, there's a lot going on right now. We can't even figure out the economics of how to launch this thing. Like it's like every week we were coming up with a plan for like how things should work, like how the airdrop should be designed, how how much tokens should be going out in the airdrop, things like that. And it was based off of a certain like launch valuation or certain estimates for like what we thought like this thing might be valued at, whatever. And then like the next week, everything would like half in price. And we were like, okay, well, we're gonna have to restart all the work again. And it would do it again. And so we were just like, okay, this is, while the market is in this situation, it just doesn't make a lot of sense for us to do this. Like, let's just table for the next 6 months and come back to it. And I think the other thing was that we were also, we had also kind of put a lot onto our table at once. We were both trying to ship the Amarok upgrade and then also the token at the same time, which is doing two things as an organization ever is just a terrible idea. That was a mistake. And now what we've done is we've now laser focused on shipping our upgrade and nothing else. So upgrade is now slated for October, as I mentioned. We're going to try to basically like probably do like alpha releases, as I mentioned, kind of have like low caps and then increase those caps over time. So we'll do like an alpha with an audit, and then like with very, very low cap, and then do another audit, and then increase the cap, and then do formal verification, increase the cap, et cetera, et cetera, et cetera. So that process might take like a month or so or two, and then I guess at the same time, once the upgrade goes live, the next item on the docket is the token. So the rest of the team is going to be focused really, really hard on making sure that happens.
Okay.
Yeah, I mean, it's a challenge, and I hate giving like timelines for things like this because you always end up disappointing people. I mean, we had like wanted to launch a year ago, like, but launching a token is an extremely difficult thing, and there's a lot of moving pieces, and then when things get delayed by a few months, you end up having to like scrap a bunch of stuff that you did and then restart all of it again, so it takes even more time. So it's hard to tell, but our goal is as soon as possible after this upgrade.
Okay, and we didn't talk about the Amarok upgrade, but yeah, maybe just a brief word on that and what it entails.
Yeah. So I mean, where Connext is right now is like it's largely used for transfers of value with like the Connext bridge, and then also by like a few integrators that have like basically put this experience as part of their application. So things like Lefi, which is the bridge aggregator, Layer Swap, which is like letting you do card payments to any chain, et cetera. One key thing that we have tried to focus on, and we've always been like a very developer-focused organization, one thing that we've tried to focus on now with this upgrade is like moving towards a world where we have fully trust-minimized, generalizable communication between chains. So our thesis, and this is similar to like the Axelar thesis and Layer Zero thesis and stuff like that, and it's been that way for a while. But our thesis is that like the future is going to be a bunch of applications that actually probably interact with multiple chains simultaneously. Like either users will be interacting with them across chains, or the apps themselves will just live on multiple chains at the same time. I think this makes sense because it's actually how the internet works today, right? Like when you are building a web application, you're interacting with resources asynchronously that are around the world via APIs, and like that's like a normal part of how you think about application development. And that's actually exactly what we're building now. Is like the Amarok upgrade introduces this new primitive called xcall. It maps in Solidity. There's a lower level function called call, which is basically just how you like interact with another contract. You just call the function. And we've created xcall as a function that kind of maps to call. And what it does is it allows you to do like an asynchronous call that goes across chains. And not only can you do an async call, you can also specify a callback. So like in JavaScript, you can go and get something from another chain, specify a callback. So when that data comes back, that callback automatically gets executed. And you can have like this asynchronous programming environment on top of blockchains that developers are already kind of familiar with.
That's super powerful.
Yeah, I think it's going to be a really, really interesting primitive, and we're really excited to see what people build with it.
Very cool. Well, looking forward to it. When's the upgrade?
So we're targeting October-ish. Yeah.
Okay, cool. We'll look forward to that. And yeah, so I mean, thank you so much for all your time here. It's been great diving deep into into Connext, and I think just talking about bridging is just so interesting because it's such an interesting space that has all the drama that you would expect and love, and then also like lots of interesting technical challenges. And so yeah, I love it, and looking forward to seeing where all these new, like the Amarok upgrade and everything, what people will be building with that as well. So thank you so much for coming on.
Absolutely. Yeah, thanks so much for having me. Appreciate it.
Talk to you soon. Cheers.